Hello everyone, welcome back to my YouTube channel. My name is Gunashri R, pursuing my third semester BE in Electronics and Communication at Sri Venkateswara College of Engineering. Today we'll be talking about the subject Computer Organization and Architecture, and subject code is BEC 306C, and my topic is Direct Memory Access DMA. What is direct memory access? DMA is the special feature within the computer system that transfers the data between memory and peripheral devices like hard drives without the intervention of the CPU. In other words, for large data transfer like disk drives, it will be wasteful to use expensive general purpose processor in which status bits are to be watched and fed the data into the controller register one byte at a time, which is termed as programmed input or output. Computers avoid burdening the CPUs, so they shift the work to a direct memory access controller. Now let's see the working of DMA. Initiation is the first step in the DMA process. It kicks off the data transfer operation between devices without involving the CPU constantly. When a peripheral device needs to transfer data to or from memory, it sends a DMA request signal to the DMA controller. This signal indicates that the CPU is not required for this particular data transfer operation. When multiple devices need to access the memory simultaneously, the DMA controller arbitrates between these requests to ensure efficient utilization of the system's resources. In bus mastering process, a DMA capable device takes control of the system bus to manage data transfers independently from the CPU. Once the DMA controller gains control of the system bus, it can directly access the memory without involving the CPU. When the DMA controller has control of the bus, it initiates the actual data movement between devices and memory. Then, the data transfer is completed. The DMA controller triggers an interrupt to notify the CPU. Once the data transfer is complete, the DMA controller releases control of the system bus. This step is crucial as it allows other devices to access the bus for their own operations without any interference from the DMA processor. Here is the block diagram of DMA. As we can see, the unit communicates with the CPU through the data bus and control lines. Through the use of the address bus and allowing the DMA and RS register to select inputs, the register within the DMA is chosen by the CPU. RD and WR are two-way inputs. When bus grant input is 0, the CPU can communicate with DMA registers. When the bus grant input is 1, then the CPU has relinquished the buses and DMA can communicate directly with the memory. Now let's see the DMA modes. There are mainly four types of DMA modes. The first one is block mode, also known as burst mode DMA. This mode allows for transferring multiple data blocks in a single DMA operation. Demand mode. In this mode, the DMA controller only transfers data when the CPU requests for it. The third mode is cycle stealing. This mode allows the DMA controller to temporarily take over control of the system bus from the CPU during data transfer cycles. And the last mode is flyby mode. This is also known as chain mode of DMA. This mode allows continuous transfer of data between devices and memory without the intervention of CPU. Lastly, let's see the types of DMAs. There are mainly four types of DMAs. The first one is single-ended DMA. This controls operation by reading and writing from a single memory address. They are the simplest DMAs. The second one is dual-ended DMA. These can read and write from two memory addresses. These are more advanced than single-ended DMA. The third one is arbitrated ended DMA. This works by reading and writing to several memory addresses at a time. It is more advanced than the dual-ended DMAs. The last one is interleaved DMA. These are the DMAs that read from one memory address and write from another memory address. So this is it for the video. Thanks for watching.